And the answer is 8. In fact, we would get all of the possible genotypes. There are 8 possible genotypes when we have 3 loci, each with 2 alleles. And we will see all of those combinations if we have many crossovers in many different meioses at random locations. Now, I should point out that although in the diagram, the simple diagram, I showed a crossover occurring between these 2 chromatids, crossovers can occur between other chromatids as well. So, for instance, there could be a crossover between those 2 chromatids, between those 2 chromatids, between those 2 chromatids. This is a situation where the flat 2-dimensional drawing is quite misleading, and the simulation that I did with the fat pipe cleaners of the chromosomes moving in 3-dimensional space is much more accurate, because you see that the chromosomes are pressed together like logs in a pile. They're not laid out flat. And so this one is just as close to this one as it is to this one. Now, all 8 combinations are possible. I'll show you the different ways that these 8 combinations could arise. We could have, as we had in the previous problem, a crossover in this interval, but we could instead have a crossover in this interval, or we could have a crossover in both intervals, or we could have any combination of crossovers. We could have one crossover in that interval between those 2 chromosomes and another crossover in that interval between those 2 chromatids. All of these are possible, but because there are only 3 genes, each with 2 alleles, there are only 8 possible combinations altogether. So what we've done in this short problem set is we followed alleles of genes on the same chromosome through meiosis, but we've considered which genotypes can arise, but we haven't yet considered at what frequency they're going to arise. And that's what we're going to do in the next lecture, which is a continuation of more problems involving crossovers. I hope to see you there.